NASA just saw a visitor older than our sun. James Webb just found the impossible. Inside an interstellar comet, the hidden truth about the visitor. From beyond our solar system, astronomers detected methane from outside our sun. For the first time, James Webb read chemicals older than Earth itself. Right now, something is racing through our solar system that most people on Earth have no idea is happening. It is small, it is fast, and it is older than our own sun. It came from a star system so far away we will never visit it. And our most powerful space telescope just cracked open its chemical fingerprint, finding ingredients frozen in place since before our planet was born. This is something NASA did not fully explain in the headlines. This is the hidden story of 3I Atlas. Welcome back to Proof, where we uncover the hidden truths of the cosmos. If you're new here, hit subscribe right now, because what you are about to hear, most people will never know. And the next part of this story is where it stops feeling like science fiction and starts feeling like a warning. It started with a faint dot of light, moving fast. On the night of July 1st, 2025, a small robotic telescope in the Atacama Desert in Chile did what it does every clear night. It scanned the sky. The telescope is part of a network called ATLAS. That stands for the Asteroid Terrestrial Impact Last Alert System. The whole reason ATLAS exists is simple. Scan the sky over and over. Catch any rock headed toward Earth early enough to warn people. Most nights it catches ordinary asteroids, rocks bound to our sun's gravity, rocks going around in loops like almost everything else in our cosmic neighborhood. But that night, the system flagged something that did not fit the usual pattern. A faint streak moving faster than anything bound to our sun should be moving. Astronomers checked the path. Within days, the math was clear. This object was not orbiting our sun, it was passing through, and it was never coming back. Before I keep going, drop a comment right now and tell me where you're watching from. I read every single one, and the place you are sitting right now is the same place this ancient visitor is streaking over. This is the part most people do not know. In all of recorded human history, we have only ever confirmed 3 visitors like this. Just 3. The first one showed up in 2017. It was named one Oumuamua, a Hawaiian word that means scout. It was small, it was oddly shaped, and it moved through our solar system so fast that our telescopes barely had time to study it before it was already gone. There was something strange about it too. It did not act like a normal comet. No glowing tail, no cloud of gas streaming off it, just a quiet rock tumbling through the dark. Some scientists wondered whether it could be artificial, whether it could be a piece of technology from another star system. To this day, that debate has never fully gone away, but we never gathered enough data to settle it. By the time telescopes understood what they were looking at, the object was already too far away. The second visitor arrived in 2019. It was named 2I Borisov. This one behaved very differently. It acted like a normal comet, with a glowing cloud around it called a coma, and a faint tail streaming out behind it. Scientists managed to read some of its chemistry, but again, it was already on its way out. Both of those visitors came and went so fast that astronomers barely had time to grab the data they needed, and every time one slipped away, scientists were left hungry for the next chance. Then, in 2025, the next chance finally arrived. The new object was named 3I Atlas. The number 3 marks it as the third confirmed interstellar object in history. The name Atlas honors the telescope network that first caught it. And right away, something about this visitor stood out. Here's the part that made the whole astronomy world stop and pay attention. 3I Atlas was moving on the most extreme path of any interstellar object ever measured. In simple words, almost everything in our solar system follows an orbit shaped like a loop, an ellipse, sweeping around the sun again and again, the way the planets do, the way most comets do. They curve gently and come back around. 3I Atlas did not. Its path was a sharp hyperbola, a line that comes in fast, bends a little near the sun, and shoots straight back out into deep space. That sharp bend tells scientists the object is moving so fast that the sun's gravity can barely tug on it. When it was first spotted, it was already moving at more than 200,000 kilometers an hour, and it only got faster as it fell inward toward the sun. But here's the part that should send a chill down your spine, because scientists know how fast this object is moving right now, and they know how the average star in our part of the galaxy moves on its own. They can work backward to estimate how long this object has been drifting alone through interstellar space. Their estimate stretches from 3 billion years old, all the way up to 11 billion years old. Our own sun is about 4.5 billion years old. Read that again. This comet might have been tumbling through the galaxy since before our sun was even born. It may have formed around a star that flared into life, lived its life, and burned out, all while our own solar system was still just a slowly spinning cloud of gas and dust in the dark. It has been out there, alone, untouched, for longer than our home has existed. And now, for a few short months, it swung close enough to our sun for us to finally read what it was made of. Let me slow down and explain something most news stories do not tell you. The Atlas system that caught this visitor was not built to study interstellar objects. It was built to protect your life. That is the whole reason the network exists. Scan the sky every clear night. Look for rocks that could be on a collision course with Earth. Catch them early enough that someone, somewhere, can do something about it. Most of the time, when Atlas flags an object, it turns out to be a harmless asteroid, another rock in our own solar system, looping peacefully around the sun. But the system is also wide-eyed enough to catch anything unusual, and that is how a telescope built to look for killer rocks ended up catching a piece of another solar system entirely. It is one of those cosmic ironies that almost feels like it was written. The same system designed to defend Earth from impact caught a visitor from beyond our sun. And it caught it with enough lead time that astronomers around the world had months to prepare. That has never happened before. With the first interstellar visitor in 2017, the pickup was rushed. Scientists got maybe a few weeks of useful data before the object was already fading away. With 3i Atlas, the lead time changed everything. It meant observatories across the planet and space telescopes high above Earth could actually schedule their observations months in advance. They did not have to scramble. They had time to plan. And that is part of why what came next is so important. The James Webb Space Telescope, often called just Webb, is the most powerful space telescope humanity has ever built. It sits about 1 million miles from Earth, parked in the cold dark of space. And it does not see the universe the way your eyes do. Your eyes see visible light, the kind of light that makes a rainbow. Webb is tuned to a different kind of light called infrared. Infrared is a wavelength of light that our eyes cannot see, but we feel it as heat. Every warm object gives off infrared light. And different chemicals give off different fingerprints of infrared, so scientists can read those fingerprints to figure out exactly what something is made of. That is what makes Webb perfect for studying a comet. In August of 2025, while the comet was still heading inbound toward the sun, Webb locked onto it and took its first spectrum. In simple words, that means it broke the comet's light apart into its chemical ingredients, the way a prism can take white sunlight and spread it into a rainbow, except Webb was reading chemistry instead of color. Then, after the comet swung past the sun in October and began to head back out toward deep space, Webb looked again in mid-December 2025, this time using a different set of instruments tuned to a different part of the infrared range. What came back surprised a lot of scientists. First, the comet released an unusually high amount of carbon dioxide compared to water vapor as it warmed up near the sun. Comets from our own solar system, the kind astronomers have studied for decades, tend to follow a fairly predictable pattern in how much water versus carbon dioxide they give off. 3i Atlas broke that pattern. It released far more carbon dioxide than a comet made in our own neighborhood usually does. That alone suggested that wherever this comet originally formed, the conditions were chemically different from the place our own solar system grew up in. But that was only the beginning. Deep in the data from those December observations, scientists found the clear signature of methane gas. Methane is one of the simplest molecules in nature, just one carbon atom and 4 hydrogen atoms locked together. But it is also one of the most fragile. Cosmic radiation, the invisible high-energy particles flying through space, slowly breaks methane apart over time, especially on the surface of something with no atmosphere to shield it. Here is where this stops being just a chemical measurement and starts becoming something almost poetic. 3i Atlas has been drifting through interstellar space with no star to warm it and no planet to protect it, possibly for billions of years. The whole time it has been getting hammered by cosmic radiation from every direction. So any methane that had once been sitting on the surface would have been wiped out long ago. When Webb detected a strong methane signal coming from this comet, scientists had to figure out where that methane had been hiding. Their answer is the part that should stop you in your tracks. The methane was not coming from the surface. It was coming from deeper inside the comet, from layers of ice that had been sealed away untouched since before our sun was born. Think about what that means. Webb was not reading the surface of a frozen comet. It was reading material that has been frozen in place for up to 11 billion years, since a time before our solar system even existed. And because the comet swung close to our sun for a short window, the outer layers finally warmed up enough to vaporize and peel back, exposing for the first time in all those billions of years the ancient chemistry that had been hidden underneath. Our telescope, briefly, was looking straight back through time, past the birth of our sun, past the formation of our planet, past the very first chapters of home itself. Alongside the methane, Webb picked up the unmistakable signature of water vapor, and something genuinely unexpected, the atomic fingerprint of nickel. Finding nickel in the gas streaming off a comet is rare. Nickel is a metal. On most comets, metals stay locked inside solid rock. For it to be showing up in the cloud of escaping gas tells scientists that something unusual was happening in the original chemistry of this object. Something interesting was mixed in when this comet first formed billions of years ago around a star in some other part of the galaxy entirely. Webb was not the only telescope that got a turn with this comet. The Hubble Space Telescope, the older workhorse that has been orbiting Earth since the 1990s, also pointed its mirror at 3I Atlas. Hubble got its first look at the comet shortly after it was discovered. And then it looked again after the comet's closest pass by the Sun, once the activity had calmed down enough for a cleaner measurement. Hubble's job was a tricky one. The solid core of a comet, called the nucleus, is tiny compared to the much brighter cloud of gas and dust wrapping around it. To measure the size of that core, astronomers have to use mathematical models to subtract the brightness of the surrounding cloud and figure out what is left underneath. The most refined measurement Hubble and the wider team could make put the nucleus of 3I Atlas at roughly 2.5 kilometers across. That is small on a planetary scale. A person could jog across it in less than an hour, but it is noticeably bigger than the cores of the two earlier interstellar visitors ever measured. And that extra size turned out to matter a lot. A bigger nucleus means more surface area. More surface area means more material warming up and releasing gas as the comet approached our Sun, which means a brighter, richer cloud for telescopes to study, which means a stronger chemical signal for instruments like Webb to lock onto. 3I Atlas was not just bigger, it was bigger, brighter, and more active, and that combination gave scientists a far clearer view of its chemistry than either of the first two visitors ever offered. A space telescope called SphereX, which was designed to scan the entire sky in infrared, also joined the effort. In December 2025, after the comet's closest pass, SphereX caught the comet becoming even more active, not less, and it picked up signs of dust particles made of tougher, more heat-resistant minerals, the kind of dust that survives a close pass by the Sun. On the ground, the ALMA Radio Observatory in Chile listened to the comet at radio wavelengths, which is a completely different part of the light spectrum from what Webb or Hubble use, and ALMA picked up additional molecules escaping from the comet, including methanol and hydrogen cyanide, 2 more pieces added to the chemical puzzle. Every instrument, working in its own way, kept adding new lines to the same story. Pause here for a second. There is something about this story that almost nobody is talking about. And it goes back to a basic problem that has haunted astronomers for years. When you look at a comet through a telescope, you are not really looking at the comet itself. You are looking at the cloud of glowing gas and dust wrapping around it. And that cloud can be many times bigger than the solid core buried in the middle. For a long time, this has made it almost impossible to get a clean measurement of how big a comet's solid nucleus really is. Astronomers have had to use clever tricks, combining brightness measurements from different kinds of light, along with computer models, to peel away the surrounding glow and try to figure out what is left underneath. With 3I Atlas, the problem was even worse than usual. The comet was bright, the cloud was thick, and the solid core was tiny in comparison. For weeks after the comet was first spotted, no one could give a confident answer to the simplest question in astronomy. How big is the actual rock under all that gas? Then, as the comet swung around the Sun and started back out into deep space, the activity began to settle. The cloud thinned out, and Hubble, looking again at just the right moment, finally got a cleaner view. The estimate came in around 2.5 kilometers. Not huge, but a real measurement of a real piece of rock formed around another star sliding through our solar system. Now here is the strangest part of this whole story, and it is the one most news outlets quietly buried. Because 3I Atlas came from outside our solar system, and because it was the third object ever confirmed as interstellar, and because it turned out to be bigger and brighter than the two visitors before it, parts of the internet went wild with speculation. Some people said openly that this comet might not be natural at all, that it might somehow be a piece of technology, a probe, a derelict ship, something built. Now, that kind of speculation is a normal human reaction. We have been wondering about visitors from other star systems for as long as we have looked up at the sky. It is part of who we are, but what is interesting is what the actual scientists did with the question. They did not wave it away. They went and checked. Researchers used radio telescope arrays specifically designed to hunt for what astronomers call technosignatures. That means any kind of artificial radio signal, a signal that would not be produced by a natural object, but would only be produced by something built on purpose. They pointed these instruments directly at 3I Atlas and listened carefully across a wide range of frequencies. They listened while the comet was inbound. They listened as it swung around the Sun. They listened as it headed back out. The result was unambiguous. No artificial signals were detected. Every piece of data, from Webb's chemical fingerprint to Hubble's size estimate to the techno-signature searches at radio wavelengths, pointed to exactly the same conclusion. 3I Atlas is a genuine natural comet, a frozen remnant from another star system somewhere else in the galaxy, formed naturally, traveling naturally, just as physics says it should. I want to pause here because I think this part matters. The real verified science behind 3I Atlas is already so strange, so beautiful, so humbling that it does not need anything added to it. A piece of another solar system, possibly older than our own, drifting close enough to our sun for humanity's most powerful space telescopes to read its chemistry layer by layer. That is already one of the most remarkable discoveries of the decade. The wild speculation online often distracts from how remarkable the actual story already is. This is the hidden truth here. The cosmos is more interesting than the rumors. If hidden stories like this are why you come here, make sure you have subscribed by now, because we are just getting started with this one. And the next confirmed interstellar object might be even stranger. So what does all of this actually mean for the rest of us? For one thing, every interstellar object scientists get to study up close is a tiny free sample of material from another part of the galaxy. Every other comet we have ever studied in detail was born around our own sun, in our own solar system. We were always just guessing about what other star systems are made of, based only on the light they give off from impossibly far away. 3I Atlas handed scientists the first real chemical fingerprint of material that formed somewhere else. That is an extraordinary opportunity. And the chance to study it in detail came down to three things: the size of the comet, the lead time before it reached the sun, and the readiness of the telescopes waiting for it. If the comet had been smaller, like the first two visitors, the chemical signal would have been too faint to read clearly. If the lead time had been shorter, scientists would have had to scramble the way they did back in 2017. And if Webb had not been ready to study faint, fast-moving solar system objects, the chance would have been wasted. All three of those things happened to line up at the same time. That is a once-in-a-decade alignment of luck and preparation. There is also a bigger emerging picture. For a long time, scientists assumed interstellar visitors were extremely rare. Cosmic pinballs, kicked out of one star system and unlikely to ever come close to another. But here is what is becoming clear. We have now confirmed 3 of these objects in less than 10 years. And the survey telescopes that catch them are getting more sensitive every single year. That means interstellar visitors might not be rare at all. They might just be hard to see. Without the right telescopes, scanning the right patches of sky at the right times, most of them would have drifted silently through our solar system, without anyone ever knowing. The more powerful the survey telescopes become, the more of these visitors we will catch. And the more we catch, the better our picture of the galaxy gets. A brand new ground-based survey telescope, built specifically to scan the entire visible sky every few nights with extraordinary sensitivity, has just begun full operations. Many scientists expect it to dramatically increase how quickly future interstellar objects get identified right after they enter our solar system. More warning time means more opportunities to line up the best telescopes in advance, the same way astronomers were able to do with 3I Atlas, instead of racing against the clock the way they had to with the very first visitor back in 2017. Every leap forward in detection technology directly translates into richer science the next time one of these ancient wanderers passes through. Let me pull the camera back for a minute and put this whole thing in its real place. This comet did not choose us. We did not choose it. It has been tumbling alone through the galaxy since before our sun was born, and we just happened to be alive when its long, slow path crossed our neighborhood. Out of the billions of years it spent drifting through the dark, it happened to swing near our sun during the few short decades when human beings had built telescopes powerful enough to read the chemistry of a moving speck of light from 1,000,000 miles away. A few hundred years earlier, and it would have been completely invisible to us. We would not have known it even passed. A few decades from now, with better telescopes in place, we will most likely find more of these visitors. We will catch them earlier. We will study them in even finer detail. But right now, 3I Atlas is the one we caught. And the only reason we have a story to tell at all is that the right telescopes were pointed at the right patch of sky during the one brief window in the entire history of the universe when this ancient traveler happened to be passing close enough to notice. That thought should change how you look up at the night sky tonight. Somewhere out there, right now, more pieces of other solar systems are almost certainly drifting through our own, ancient, frozen, completely unnoticed by anyone on Earth. They were never rare. They were always out there. We just did not have the tools to see them yet. Tell me in the comments what part of this story surprised you the most. The age, the chemistry, the idea that our solar system is being quietly visited by other solar systems all the time. Share this with someone who still looks up at the sky and wonders what is really out there. Because the real story behind 3I Atlas, the one grounded entirely in verified science, is stranger and more beautiful than anything the wildest theory ever imagined. And, as always, thank you for exploring the hidden universe with proof. We will see you in the next one.